In this demo, I'll show you how to control output pins in either bank A or B, and using the lower level wire library or the Arduino library. Just adjust your circuit so that it contains a second LED connected to pin 1 on the port expander, which is also named GPB0. First, we'll get both LEDs to blink using only the wire library, and then we'll do the same thing using the Adafruit library. So, for the second demo, we just need to plug in a second LED on bank B of the IC, so there's not much more to do. So let's plug this yellow LED. I'm going to put it here, like that, and 220 ohm resistor will go here. It's tricky. Alright, that's all there is to it. So I'm just using GPB0, which is pin number 1 on the IC. So plug the Arduino into my computer. This is the previous sketch, so it's blinking the red LED. So using just a wire library, let's upload the new sketch, make sure that everything works. Alright, so now both LEDs are going, one connected to bank A and the other one connected to bank B. So looking at the sketch, it's basically a duplication of the code from the first sketch. Here's the code that turns bank A into an output, and here's pretty much the same code that turns bank B into an output. You can see here that I'm selecting IODRB register and then turning that into an output. When it comes to the loop, I've got the delay, and I select the device first. It's listening to address 20. Select bank A, send it a byte which contains 1 for the first bit, and that turns the bit, the LED, that pin on. Then I do exactly the same thing. So select the same device. Now go to the second bank. So this is a register that controls the second bank, and send it a byte, which this last bit, so the least significant bit, is 1, so it turns the LED connected to port 1, pin 1 on the IC, on. And down here I'm doing the exact opposite, so select the same registers, bank that correspond to bank A and bank B, and then send the appropriate byte to them, they're both zeros, so they turn the yellow and the red LED off. Now, if you're wondering where to get information about the names of these registers or the addresses for these registers, the answer is the datasheet. So the datasheet contains all of that information, gives you examples on how to turn things on and on. So, for example, this is where I'm selecting register for bank A. Now the documentation gives me the address for that. This is where I select the register for bank B. The documentation gives you that information. So there's a lot to read and understand how the chip works internally. Luckily, all that is abstracted thanks to the Adafruit library. So let's do the same thing now with by using the Adafruit library on top of the wire library. So I'm sending it first to make sure it works. Yep. It's all good. So exactly what we did earlier, but now we just add another pin into our mix. So this is going to be pin 8 or pin ID 8, which corresponds to pin 1 on the IC. Then I'm turning pin ID 8 high and wait for a little while, turn it low so it switches off the LED. So much simpler doing something like that than something like this. Of course, the overhead is about 1,000 bytes. So if you've got space to spare, much better to use the Adafruit library. In this demo, we'll connect a button to one of the digital inputs. When the button is pressed, the LED connected to a digital output will be turned off. So here's a circuit. Just add a button to pin 21, which is also named GPA0. Don't forget the pull-down resistor 10 kilo ohm. The sketch reads the state of the button and updates the state of the LED. We are just going to use the Adafruit library for this. So for the last demo, I'm going to bring in a button to the mix. So this button, when I press it, is going to turn this LED on. When I let it go, it's going to turn it off. So the LED is still blinking thanks to the sketch from demo 2. Plug the button in. I'm going to ground it via a pull-down resistor, 10 kilo ohm pull-down resistor, and bring the other pin to high. And when I press the button, I'm going to activate GPA0, which is pin 21 on the IC. This one here, hopefully I'm right. Alright. So, done with this. Let's upload the sketch and see if it works. Alright, pressing button. Yep, activates the LED. So what I've done is that I've configured GPA0 to be an input, reading the state of the button, and GPA7 being an output and controlling the state of the LED. Let's have a quick look at the sketch. So I'm using the Adafruit library for this. It's much easier. Again, creating the object just like earlier. Now this is where the difference lies. So pin 7, or input output pin 7, is an output, and then input output pin 0, where the button is connected, is turned into an input, configured to be an input. Then in the loop, I'm reading the state of the button using digital read. So for pin at ID 0, and then I'm using, just like before, digital write to change the state of the LED, which is connected to IO7. And that's all there is to it. Using the MCP23017 port expander is almost trivial. The Adafruit library hides all the low-level details without adding much fat to the overall size of your sketch. In my estimate, it adds around 1,000 bytes to the amount of memory that the Wire library requires. You could also use the MCP23017 as an I2C based shift register and control 16 LEDs or an array of 8x8 LEDs. Just remember that each pin can provide a maximum of 15 milliamps, so you will need to consider your display's power requirements just like we've done in previous LED lectures. You can also control relays and through them much larger loads like motors and lights and make this part of your home automation system.